obligatory science fiction reference. So before we get into it, here's a typical Python stack. A sort of basic Python stack, then a data science one, probably use Jupyter Notebook, Matplotlib and Seaborn for plotting. For scraping, Beautiful Soup, LXML, Selenium, Chrome driver are pretty common, pretty standard. For machine learning, scikit-learn, and then PyTorch for deep learning, XGBoost if you want tree-based. And for NLP packages, Spacey, Hugging Face for transformers, which we'll mention later. If you use Spark NLP, and we'll talk about topic modeling and large language models. You can download all this stuff for free from Hugging Face or from Meta or other open AI pages. So we don't have time to cover all this, but there's some fantastic tutorials from previous PyCons and from other user groups. You can find a lot of this stuff out there. So I encourage you, download this stuff today if it sounds cool, start hacking, try to build your own model. If you hit a roadblock, go on Stack Overflow or PyVideo, and you can find a ton of useful people. And for macOS, here's some suggested package handling and environment manager for macOS. So, what are we going to talk about today? Scraping, programmatically understanding and scraping top topics from Python conferences. This is a typical slice of conference abstracts. The left column is in Spanish, obviously. The second column, a perfect match, the history, design, implementation, and future of Python structural pattern matching. That's pretty good, sort of like dry academic style abstract. The third, fourth, and fifth ones are interesting for several reasons. So for the third one, we need to understand that animating NFL play-by-play data, we need to understand NFL equals American football, so sports data science, using Matplotlib's func animation. So presumably we recognize Matplotlib as a common plotting package, and func animation looks like a function name, so seems like that speaker is talking about the internals of plotting. The fourth and fifth ones are sort of even further out in terms of understanding, because the speaker is using a metaphor or some color text or narrative which isn't strictly relevant. So for the finding penguins with a snake, really we want to understand this means Linux features for Python user and ignore the first part. It's not about a menagerie. And the fifth one, really the only relevant word in that abstract is graphs. You're going to see his abstract later on. So, as I say at the top, how do we machine understand this stuff? How do we machine understand which bits are relevant, which bits aren't? Which things are a package name? How do I know in the fifth one that Dungeons and Dragons isn't a Python package? How do I know that func animation is a function, not a person or a library or a company name or something, or an API? Things like that. So how would we go about programmatically scraping this from the web? So firstly, extract the content from the HTML or CSS, JavaScript, or other formats. Then we put it through an NLP pipeline. So in this talk, I was using Spacey. You can use any NLP, any open or licensed cloud vendor pipeline. But there's a common bunch of things you're going to do in the pipeline. Obviously, try to detect the language, normalize text, do basic functions like stop word removal, recognize that any or means named entity resolution. We have a few slides, we're going to talk about that. Essentially, distill the thing down to the keywords or the key terms that characterize the topic. And then when we have those, then we can pass them through a topic modeling algorithm which clusters and looks for similarity. So for example, all the talks about sports data science or visualization or pandas or something, or internals of Python, we can cluster those similarly. So as I mentioned, the name entity resolution part, NEOR is this canonical concept in natural language processing. How do we recognize that something is the name of a tool, not a package, not a language, not a company, or a methodology, or a concept, or a place, things like that. So US, USA, United States, EEUU are all references. They have to be resolved by our NLP to the same entity. But there's harder things like, if we mention Go in the abstract, are we referring to Go the language, or Golang, or just the verb? If we're talking about token can mean different things in different contexts, and it kind of almost changes every month now. So are we talking about crypto, blockchain, Web3? Are we talking about API, two-factor authentication, stuff like that? Or maybe we're just referencing the English word token, like neither of those. If we're talking about, if we use the word React or Anchor, maybe that's a reference to the JavaScript package, maybe it isn't. If we use the phrase POC in an abstract, did that mean proof of concept or people of color? Maybe it even meant point of contact or point of care in a medical study. And as you're going to see later on, sometimes abstracts are very sparse. They're just like literally 20 words long. You have to go and inspect the metadata, look at the speaker, look at their affiliation, look at their Twitter handle, look at their other talks, look at their bio, which may be stored elsewhere on the conference page. It may be stored externally. You might have to go look at their Twitter or LinkedIn. And in order to disambiguate, how do we expand POC? How do we expand that entity? So then number 6, Desiro 200 que en 30 minutos. How do we understand, ideally we want to be able to understand that that's idiomatic. It's equivalent to saying quick start or 0 to 60 or whatever, 0 to 60 miles per hour. And obviously you need to understand that that's Spanish, or you can't unpack that idiom. Some other things that are going to be challenging, there are very different, there's academic style, there's sort of conversational style, there's anecdotal style. One abstract was called alternative history retro computing. But another abstract style might simply be, remember when people wrote their first game in BASIC on a Commodore Amiga? And you're not going to be able to understand that unless you can look up something which tells you BASIC is a general purpose beginner language, or at least it used to be a couple of decades ago. Commodore Amiga is a retro computing, whatever, 1980s architecture. So as I mentioned, an ontology is the thing that we would need to look up, or some sort of a data model. Typically in ontology, it might be represented as a knowledge graph, it might be represented as something else. But in general, ontology is the thing we're going to use to disambiguate what is the meaning behind something. So for example, if you use IMDb, you're already familiar with the concept that you have a model of films, characters, actors. So for example, The Martian is a film, Mark Watney is a character, Matt Damon is the actor, director is Ridley Scott. The genres might be whatever, space, drama, whatever, escape, stuff like that. So we can have all sorts of ontologies for different domains. So a point I'm trying to stress in this talk, understand in the sort of machine sense, it only goes so far. It only really makes sense in context of some explicit or implicit use case. So if I'm trying to rent you a DVD of The Martian and I'm writing a recommender system, I don't really care what it means to say that somebody's stranded on Mars. But if I'm writing a novel or trying to understand it at a deeper level, or trying to say which 19th century Jules Verne was this similar to, then I need to understand it better than that. And the terms we use, they're often ephemeral, they're time varying. So if an ontology was only trained on 19th century literature, Escape from Mars isn't going to make any sense to it. So more contemporary example, if somebody says crypto, if somebody said crypto in 2009, they probably meant encryption. If they said crypto in 2014, maybe they're an early adopter of Bitcoin. If they say crypto in 2022, they probably have a different take on that. So the point there is, the term, it's time varying. We would want to, ideally we would want to build or have or look up or build our own model that resolves that stuff, and that stuff is non-trivial. So you can get an off-the-shelf ontology. Wordnet just tells you the meanings of words, like a thesaurus. It doesn't go much further. You could look up Wikipedia, you could build your own, you're going to have to clean it, you'll have inconsistencies, things that aren't up to date. If it's domain specific in any way, you're going to have to brew your own. If you do this at scale on any of the large cloud vendor platforms, you'll probably end up either building your own model, licensing theirs, or taking some combination. You might use Amazon Comprehend, Microsoft APIs, Google Cloud, Baidu, something like that. So returning to the more problematic or colorful sort of narrative teaser clickbait style pop culture reference type abstracts, we're going to have to, in order to understand these, so for example, number 9, the Dungeons and Dragons metaphor, how do we know that MacGuffin isn't the name of an author who wrote a package like Wes McKinney? We can either explicitly or implicitly programmatically learn that's just a sort of cultural totem for mysterious object that should be ignored. And in the same sense, really the last sentence here, the goal of this talk is to develop an intuition-first understanding of common graph algorithms. And that's essentially the payload is at the end, as it often is with these abstracts. So we really want to ideally ignore or pay very little attention to the first few lines of narrative. And the number 10, this is an abstract from PyCon UK 2022, unexploded bombs, and the author starts with this elaborate metaphor about a World War II ship sunk in the Thames estuary. But really, all we want to pay attention to there is using this as a metaphor to explore ways to make code safer and more robust. And the number 11 abstract I mentioned, threat analysis from exposed RDP. And again, you have to be able to programmatically understand RDP as remote desktop protocol. That's the most important part here. And then you understand this is about network security. So how are all of these? These are different to a quote unquote typical NLP problem. As mentioned, you may be missing the context, the metadata, the speaker affiliation, the bio, stuff like that, the web page. How do we expand ambiguous or non-trivial acronyms? Even stop words might not be stop words, so Go might mean Golang, React might mean JavaScript package. And then you're going to learn domain-specific or package-specific or Python-specific terms. So if a talk is about GIL, the infamous global interpreter lock, then we're implicitly talking about performance, specifically runtime performance of the C Python interpreter, and probably multi-threading. So all of that context is kind of implicit in an abstract. Then I'm going to skip over, I can show code for sake of time. I have code that does the scraping from a bunch of different conference abstracts. It's quite tricky, it's programmatically interesting. There's lots of considerations. First, before you get to the programmatic part, the question of is scraping a certain website for a certain purpose? Is it good? Is it legal? Is it ethical? Depends on what the TOS say, depends on what case law says. Even if it's at first glance it's okay, the data is public, or you're not intending to use it maliciously, there's some obvious considerations. Don't hit the thing as like a DDoS attack or something. So you might rate limit yourself. It's probably nicer to scrape a site, all of the things being equal, at 3 a.m. on Sunday morning than a busy weekday. Use caching, use persistent storage, things like that. So minimize your environmental impact. And then beyond that, even if a site doesn't explicitly say we will ban you or blocklist you or whatever if you do these things, a site will typically inspect your user agent, your browser fingerprint, all of these things. They look for non-human-like behavior, strange rates, strange trajectories. Typically, if you go to an e-commerce site, no human would go to Amazon and would search for every single listing in Power Tools and would then spider or crawl them down to the bottom, a sort of depth 7 search or something, and do that every 10 milliseconds. That's not a human trajectory. So sites have lots of heuristics. They look at your browser type, they look at your referring URL. If you come in from an IP address in, say, Europe, but your referrer was google.jp, they'll say that looks unusual. If you use Firefox, but your user agent suggests you're using Internet Explorer, they'll say that's unusual too. So then beyond that, practical considerations for scraping, especially since COVID and since 2019, some conference web pages, They went up, they went down, they rescheduled. Some of them are 404s, some of them are redirects. Some of them, they say PyCon 2019, so for the sake of time, I'm not able to show you, I think I'll show you some web pages after. So for example, PyCon Canada, it was repeatedly postponed, even virtually. I don't believe there has been a PyCon Canada since 2019, but if you look at pycon.de, the German one, or other countries, you will see that some PyCons were announced. They had a date, they had an official date, they had a venue, and then they were pulled at the last minute, or they went hybrid only, or virtual. So in the web scraping sense, you need to be able to handle all of that stuff. What's my HTTP status code? What's my language encoding? I might have multiple languages on a page. I have to be able to parse that stuff. I have to be able to extract, in some cases, extract the venue information or the exact date or the URL, stuff like that, from the meta tags or maybe table headers. Then beyond that, once we successfully get on the conference page and we start downloading the content, we might have to navigate a bunch of different formats. We might be the conference listings might be in static HTML. They might be paragraph tags. They might be CSS. They might be dynamic. If it's dynamic, then we probably have to use Selenium or Chrome WebDriver. It might be in good old JSON. It might be in a calendar format, like XCal or iCal. Frab is another format that open source people use. Sessionize is actually the app and the format that PyCon Ireland has been using for a couple of years. So you can find multiple formats on conference pages. Should I skip to an example, or should I? So for the sake of time. Okay, so I'll just briefly mention I'll mention the NLP pipeline part. So assuming that we've ingested from scraping, then we have to run the abstracts through a pipeline. Here's on one slide. Here's an overview of 60 plus years of natural language processing. So if you've played with natural language processing, you're familiar with basic concepts like stop words, part of speech tagging, tokenization, things like that, and classical methods of analyzing documents based on counts of words, bigrams, term frequency, inverse document frequency, stuff like that. Then in the last decade, we get embeddings or word vectors. So if you've heard of word to vec, para to vec, doc to vec, even song to vec, image to vec, all of these things seek to represent a document as in an arbitrary length vector space. And then more recently, we get the deep learning-based approaches. PyTorch is a really nice package developed by Facebook that wraps TensorFlow. And then even more recently, we get transformer and BERT architectures, which are really powerful. And the key innovation with those is attention, which means the architecture learns the weights of, it learns the relation between words in an arbitrary sequence in a sentence. And it learns that words that might even be linguistically distant are connected. So if you say something like, I went to the bank, I did such and such, then I opened an account and I transferred it. In that sense, bank and account are words that give each other context, even though they're not, they're quite distant from each other in a sentence. You can download and play with transformers for free. You can download Hugging Face is a very popular package. You can also download large so-called LLMs, large language models, which have been pre-trained based on large corpora. Hugging Face has some, Facebook has some, and some of these they have millions or billions of parameters, and they're trained in very large corpora, whether web documents, medical documents, scientific documents, stuff like that. How are we doing in time, guys? Are we over? Okay, sure thing. So then after we ingest we do the scraping, we ingest, and we do NLP, and we extract some topic names. Then there are algorithms for topic modeling to detect the similarity and to automatically cluster similar names, even if they're linguistically very dissimilar. So, for example, if you said something like, how I wrote a program to teach my 9-year-old to play battleships using whatever, matplotlib and whatever, pandas or polars. And if somebody else had language for a similar, an abstract on a similar theme but different language, like something like whatever, game programming tutorial for beginners, those should be clustered as being similar topic, even if linguistically, if you use something naive like say cosine distance or Jacquard distance or something, you will find that they have almost no overlap. So GenSim is a very popular package. LDA is pretty much the universal algorithm for topic modeling. There's a deep learning package called BERT Topic. There are some others, and they intend to use transformer architecture to apply the power of deep learning to topic modeling. Okay, so should we go to Q&A, or do you want to see some? Would you like to see some abstract web pages, or should we go to Q&A? Votes. Show you some abstracts. Okay. Okay, so this is EuroPython. Let's pick maybe the simplest is the PyCon US, I think. So this is a sort of static HTML table. So it's nice to parse in that sense. Here we have a first table is tutorials, whatever, equal to 27th. This is PyCon US. The metadata tells you that it was in, I think, Salt Lake City this year. So the first table is the tutorials day, whatever, April the 27th. Second day tutorials, sponsor workshops, some talks. You can see what's interesting about this abstract. You can see there's a Spanish track, and it doesn't actually explicitly label that. You just have to, your parsing would have to understand that. Okay, so that's I can show my run. This is my code running on PyCon US, and extracting all of those tables. And then in the code, what my code is going to do then, we're going to annotate it with other things like, is this a sponsor workshop? Is it a keynote? What day was it on? Stuff like that. Is it lightning talks? And store it in a SQL database. Okay, here's PyCon 2020, largely similar. Here is Australia PyCon. This is not even a HTML table. This is, I believe this was CSS. Oh no, it's just anchor. Yeah, it's a mixture of CSS and anchor tags. So you have to generalize your table recognition code to do that. This is PyCon Argentina. And I think this one is CSS. Okay, now some mixture of dynamic content and CSS. Should we go to Q&A now? Or?
Yeah.
Okay, how are we doing on time?
You can take 2 questions.
Okay, sure. So.
You can take 2 questions, so.
Hi, Stephen. Thanks a million for the presentation. It was very good. I just have thoughts. I see there's a new tool called DALL-E 2 out recently. It's taken, you put in a paragraph and it can give you pretty good image construction. I was thinking a general question. How far do you think video, like say take a paragraph of a story to video construction, how far away are we away from that? Is there more optimization that needs to be done in NLP before we even look at reconstructing stories with videos and images? I know we're not there with DALL-E 2 yet either. Just kind of general thoughts on how far away we are from that, even in years, or what do you think?
Right, so they call that like NLG, natural language generation. There's also NLU, natural language understanding. That's sort of separate but sort of sister area. I don't follow it very closely, but you've probably seen a lot of very active recent stuff about copying or plagiarizing, or however you want to characterize it, image styles of animators. This is very controversial. So I think there's a huge amount of interest in that. If you know, there's also stuff like deep learning based script writing. So you could write the text script of a film, and then you could translate it into images. So I think there's a ton of deep learning technology there. There's some very obvious ethical issues and copyright issues. All I can say is it's a very active space, and it's changing every week. You know?
Oh, thank you very much.
Anybody else?
So we talk about the bias in NLP data and textual data. So could you please recommend some of the libraries that we can use to mitigate that type of risk and bias associated with the data?
Okay, sure. So when you say mitigate, it's kind of like there's a whole school, you know, there's a whole study of that sort of stuff. And if we mean something like bias in job listings or bias in search, I mean, the best thing I can say is refer you to, there's some pretty good conference presentations and articles and that stuff. It depends entirely on how you define the domain. So, you know, there's a canonical example, I forget which company, but they trained it on job descriptions of existing employees. And it learned things implicitly like, you know, doctor equals male, nurse equals female, and so on, or, you know, intern, student. In some companies, it learns that it learns to associate gender or ethnicity or other things, which school you went to, stuff like that, what your nationality is, what your native language is. It learns to associate that stuff implicitly with, let's say, your job, your salary, or your job title. And there's the whole sort of criminology and predictive bail, all these things, predictive sentencing. And the problem with that stuff is it's very hard to, you have to define the problem, you have to frame it, and you have to explicitly try to remove bias. So there's a ton of active study in that. One of the obvious considerations is if your input data set is biased, the model you train simply learns the input distribution. That's something you have to be aware of, and then that sort of raises questions about data curation. Yeah, the best thing is to refer you to some of the other articles. Okay, well, thanks so much, guys.